The jungle.
Demo. As you can see, it is rather simple. We model our search like Google. So, for example, we have a search query that asks the system that the movie's rating is more than 3.5. So, we press the search button. So, what does this do is it returns the results that has more than 3.5, or the star rating that is more than 3.5. So, once the user is satisfied with the results, you can press the back button and you can go for another search. So let's see another search. For example, if we have no keywords such as Tony, some random things like Tony, so what does the system do? It will actually return all the results that is Tony. Yep, as you can see. So how is this all possible? It's actually from the Solar itself. The Solar index all of our data.
We have decided to crawl data from Amazon Prime Video, which consists of movies, dramas, documentaries, and many more. We have chosen to use Scrappy as the framework to crawl the data we needed. So basically, Scrappy has three main steps. The first step, which is to define the data to be crawled. From here, you can see we want to crawl the data such as the title, description, and the genres. The second step is to define the spider, which is the method for crawling. So we have to define the start URL, define the rules for extraction, and lastly to define the items you want to yield inside the pass item function. Lastly, we just have to run the spider itself. So from here, you can see the data format for our crawled data. We have the title, the genre, the title 13, the genre horror, the star rating of 2.1, with captions and subs, English, and so on and so forth.
Hi everyone, I'll be talking about the classification section in our project. So under classification, before we start any methods, we have to pre-process data. Under pre-processing, this is what our group has done. First, we did an annotation of the data. This is done manually by members in our group. Subsequently, we also remove the stop words. Stop words such as the, there, how, and many others are being removed from our dataset. We also identified the top 10 words that is found in the description column of our data. From the same column, we also found the words that are being more associated with the labels. Once all the pre-processing steps has been done, we can now proceed to classify our data. One of the steps that we did for classification is a neural network. Under neural network, we did a cascade forward network. This includes a connection from the input and every other previous layer to the following layers. As can be seen from illustration as shown below, there is a total of 39 inputs that we use, and these inputs are being passed into the hidden layer of the neural network. The output layer will then show us the predicted values from the neural network. In the confusion matrix, every value that is being highlighted in green refers to the true positive that is being predicted by our network. As seen here, there is a total of 46.1% accuracy rate from the neural network predictions. Using naive Bayes, we involve the use of the Bayes theorem with independence assumptions. This means that every single condition in the dataset is assumed to be independent of each other. The naive Bayes method is easy to build and is also relatively useful for very large datasets. The confusion matrix for naive Bayes is as follows. Similar to the neural network, those highlighted in green are the true positive that has been predicted by this method. There is a total accuracy of 47.6%.
Next, k-nearest neighbor. This is one of the simplest classification algorithms. So KNN is a non-parametric lazy learning algorithm. The distance function used in this case is Euclidean distance and the k values is specified. The result, which is a genres in this case, is predicted based on the k-nearest neighbor. So as you can see from the confusion matrix here, the accuracy is at 53.3%. Next, decision tree. This is a non-parametric supervised learning method. So a decision tree requires little data preparation and is simple to understand and interpret. This method predicts the result by learning simple decision rules obtained from the data features. So as you can see from the result here, the accuracy is at 52%. So for the visualization aspect, the data are being categorized into four main categories: titles, directors, genres, and description. So when you click on any one of these categories, the data below will be separated accordingly. So for example, when I click genres here, it will be separated into the different sections such as comedy, documentary, horror, kids and family, and lastly music. So this is in alphabetical order and it works the same when you click title, director or description.